Okay, hi, so good day everyone. So this relates to example number 1. So it says tell whether each ordered pair is a solution of the system of linear inequalities. So what we're given is our system of linear inequalities. The first one is y is less than 4x. Second inequality, y is greater than or equal to x minus 1. And the third inequality has y is less than or equal to 2x plus 1. So we're going to see if we plug in these points, a being 1, 0, and b being -2, -8, if those points are going to be solutions to our system of linear inequalities. Okay, so the first point that I'm going to start out with here is going to be a, which is 1, 0. Now remember what I said in the last video is that 1, 0 will have to work in all three inequalities. So give me just a second. I want to set this up for you. I'm going to let, in all three cases, I'm going to let x be 1 and let y be 0. So if you feel like you got this, I want you to pause me and go ahead and try it out for yourself. I'm just going to pause to set everything up. So you can try to set it up on your own and then come together with me to see if 1, 0 is a solution. Okay? Okay, folks, so here's what I did. I have inequality 1, 2, and 3. I just wrote down the same three inequalities that were given up here at the top, and I substituted in a 0 for every single y and a 1 for every single x. So all I did first was substitute in the values that I was given. Lost my word. Substitute in the point that I'm given to see if it is a solution. So here we go. I'm going to simplify some things, then multiply if I need to. So here we got 4 times 1, and 4 times 1 is 4, and we have to see if 0 is less than 4. So this is true. This works out. 0 is less than 4, so 1, 0 is a solution for this inequality, but we have to see if it works in all three cases. So here we have 0. We're not doing anything with that, and we have to see if that's greater than or equal to what happens when we subtract 1 minus 1. 1 minus 1 is 0, and 0 is actually equal to 0. So this works out. That's true. So then over here we have y is less than or equal to 2x plus 1. We have to do two things here to simplify. So the first thing we need to do is multiply 2 times 1, and we get 2 plus that same 1 that's here, and we need to see if 0 is less than or equal to 2 plus 1. 2 plus 1 is going to be 3. 0 is less than or equal to 3. So that means that in this case, in all three inequalities, the point 1, 0 worked. So 1, 0 is going to be a solution to this system of linear inequalities. So I'm going to just make a note of that and say the point 1, 0 is a solution to our system of linear inequalities. Okay, so this is true. It worked in all three cases. Now what I want to do, I have this next point here, which is -2, -8. So I want to see if -2, -8 will be a solution to our same system of linear inequalities. So give me just a moment. I'm going to set that up for you. Everyone, so I did have to change the color because this peach color did not show up very well. So I am referring to this point here. For every y, I let it be -8, and for every x, I let it be -2. So I substitute that into all three of our inequalities, and I'm looking to see which one gives me a true inequality. So here, the very first one we have here is -8 is less than 4 times -2. So we have to multiply here, and what we're going to get is that same -8 here, our less than sign, and here we have a -8. But that's not true. Negative 8 is not less than negative 8. That don't work. This is not true. And because this one is not true, that means that we don't even need to go into those. But hey, I will. Okay. So this one didn't work. So let's see if the other ones don't work too. Why not? So we have a negative 8 on the left-hand side. And we need to see if that is greater than or equal to negative 2 times negative 2 might. Uh-oh. I put the wrong thing right there. Let me fix that. Excuse me. Minus 1 should be. So negative 2 minus 1, that's like me borrowing $2 and borrowing 1 more. That's a negative 3. And so a lot of times students get tripped up with this part, with negative 8 being greater than a negative 3. Think about a number line and where things lie. Okay, so we would have a 0 here, negative 3 would be here, and negative 8 would be somewhere way over there. Now, it's true that the numbers to the right, the numbers get larger, so it gets greater. So in this case, negative 8 is not greater than or equal to negative 3. This one is also not true. And listen, if you have to draw yourself a little number line, then you just do what you got to do, okay? So I'm going to try this one here, this next one. You have the same negative 8 on the left-hand side, and 2 times negative 2, that's a negative 4 plus 1. And so here we'll have negative 8 is less than or equal to, we have a negative 4, whoops. It's out of focus. There we go. Negative 4 plus 1. That's like me borrowing $4, but I only paid you 1 back. So it's still a negative 3. Now, this right here, we have negative 8 is less than or equal to negative 3. This one is true. But I'm going to tell you something. Because these two right here were not true, we can say that negative 2... Uh-oh, can you see it? Negative 2, the point negative 2, negative 8 is not a solution. Now, also what I want to say is once we get to this point, we really don't have to look at the other ones, okay, at all. But I just did it as good practice for looking at integers on a number line, okay? So hang tight. We're going to do another example of determining if we have a point that is in a solution for our system of inequalities, linear inequalities. So give me just a moment to set that up for you.